Good morning, students. Today we are going to learn about electricity. Children, in this chapter we are going to learn about charge, properties of charge, methods of charging, and electricity, electric current, electric field, electric potential, and potential difference. Children, what is charge? Charge is the inherent property of matter that feels force of attraction, out repulsion due to excess or deficiency of electrons. So it is the two types of charges are there: positive charge due to electron deficiency, negative charge due to excess of electrons. So why it is called positive charge is that due to electron deficiency. So positive charge will become when electrons are transferred from object to object. It becomes positive charge. Negative charge means what? When electrons are received from other object. It's called as negative charge. Okay, children. Now, its SI unit is coulombs, denoted by capital C. It is detected and measured using a device called electroscope. For example, children, here observe some pictures are here. Electrons are put into ebonite rod. Fur cloth is there here. The positively charged pith is attracted to the negatively charged rod. Electrons rubbed off glass rod. This silk cloth is there. Okay, leaving its positively charged. So, for example, metal disc or copper wire, aluminium foil. Now, what are the properties of charge? The total charge of the universe is conserved, that is constant. Like charge attract each other and unlike charge repel each other. Charges are additive in nature. Charges are always quantized, that is Q equal to N to C, where Q is equal to charge, N equal to number of electrons, and E is equal to charge on one electron, that is 1.67 into 10 power minus 9 coulombs. Charge is relativistically constant. So methods of charging. How to charge? First is conduction, charging by conduction. When an uncharged body is brought into contact, touched with a charged body, then the charge of our electrons are transferred from the charged body to the uncharged body. This charges the uncharged body. Charging by induction. In the induction process, a charged object is brought near but not touched to a neutral conducting object. The presence of charged object near a neutral conductor will polarize the charge within the conductor. Then what is electricity? Children, electricity is a form of energy that can be easily changed to many other forms. It can also be defined as flow of electrons in a circuit. So, electricity means it can define flow of electrons in a circuit. Electric current. So, what is electric current, children? It is the rate of flow of electrons, charge or electrons through a conductor. I equal to Q by T or NE by T, where I stands for current. It is a scalar quantity. Its SI unit is coulomb per second or amperes. It is measured by a device called ammeter. Its direction is taken opposite to the flow of electrons. Its flow as a result of potential difference across the ends of a conductor. Children, observe the figure is given here. You can observe the figure here. Okay. Electric field. It is the three-dimensional space around a charge in which the force of attraction or repulsion can be felt. Electric field intensity. It is the force experienced by a unit positive charge when placed near a magnetic field. It is denoted by capital E. Its SI unit is Newton per coulomb, N by C. It is a vector quantity. Electric potential and potential difference. It is the amount of work done in bringing a unit positive charge from infinity to a given point in the electric field. It is a scalar quantity. So what is means scalar quantity, my dear children? Scalar quantity means the physical substances or physical quantities which have only magnitude but no direction are called scalar quantities. The unit of electric field is SI unit of electric field is joules per coulomb or volts V. Potential difference, it is the amount of work done in bringing a unit positive charge from one point to another point in electric field. It is a scalar quantity. Its SI unit is joules per coulomb or volts. It is responsible for the flow of current in a conductor. Measured by a device called voltmeter. Next, Ohm's law. So what is Ohm's law? It was stated by George Simon Ohm. It states that at constant physical conditions like temperature are kept constant, then the amount of current flowing through a conductor is directly proportional to the potential difference across its ends. That is I directly proportional to V. And V is equal to IR, where R is constant, called resistance. According to this law, conductors are divided into two types. They are ohmic conductors, follow Ohm's law, and non-ohmic conductors do not follow Ohm's law. Ohmic conductors means the conductors which obey Ohm's law are called ohmic conductors, and non-ohmic conductors means the conductors which do not follow Ohm's law are called non-ohmic conductors. So that is I and V graphs for conductor, children. For ohmic conductor, the graph line will starts from origin and moves in the form of straight line. But non-ohmic conductor, you observe here, it is a curved line. Resistance and resistivity. Resistance means it is defined as the hindrance to the flow of current. It is the ratio of potential difference to current, that is R equal to V by I. The SI unit of is volts per ampere or ohm divided by ohm symbol. Reciprocal or resistance is called conductors. The SI unit is per ohms, that is for ohm. So high resistance, low current, low resistance, high current. Symbols are given, children, here. High resistance, low current, low resistance, high current. Factors affecting resistance. R directly proportional to length. R inversely proportional to 1 by area of cross section of conductor A. So from 1 and 2 and 3 we get R inversely proportional to 1 by A, R equal to rho 1 L by A, where constant rho is the specific resistance of the conductor. Specific resistance. Specific resistance is the resistance of a conductor of unit length and unit cross section area, that is, if L equal to 1 meter and A equal to 1 meter square, then R equal to rho. It depends on material of the conductor divided by the rho. Symbol of rho is RHO. In words you can write RHO rho. SI unit of ohm meter. So P P directly proportional to temperature of the conductor, also known as resistivity.